we are dealing with a customer services call center, and we've been given information in regards to the mean, which I have represented here, and also the standard deviation is unknown, which we're representing with the sigma. This is a normal distribution. You want to make sure that you use the right notation for a normal distribution, where x is a random variable, continuous random variable, which is normally distributed with our mean and then sigma squared. So for part A, we've been asked to show that to three significant figures, the value of sigma is 4.68, given that 10% of the course take longer than 22 minutes. So the first thing I'm going to try and do is draw a diagram. So let's get a normal distribution, bell-shaped curve, and I know that the mean is 16. Now this information I want to try and represent on my diagram. Before I do that, I'm going to represent this information using inequality. So the probability that x is greater than the longer than 22 minutes is equal to 10% or 0.1. This will help me because now I know I'm looking at greater than, which means I start shading from the right, and 10% will be represented by this area. So that's your 0.1 or 10%, and this is 22. So that information I have been given. If I want to work out what sigma is, you will need to use this information, and it's basically trying to work out the unknown value of sigma. So I could do that by using a standard normal distribution with mean 0 and sigma 1. If I bring this down and standardize, if I standardize this, just to remind everybody, standardizing means z is equal to x minus mu divided by sigma. So this will be 0, 22 minus mu, which is 16, divided by sigma, and that's equal to 6 over sigma. That's my z value. I can draw another diagram here to actually work out what that z value is. So this is the way I teach this to you. Z is again normally distributed with 0 and 1 squared. So this z value I can work out because I know that this area here is represented by 10%. On my calculators, you can work out using inverse normal what this z value actually is. Now your calculator's inverse normal works from left to right. So the area from left to right is 1 minus 0.1, which is 0.9. So all you need to do is, on your calculators, inverse normal, area equals 0.9, mu equals 0, and the sigma equals 1, because I'm using a standard normal distribution. And this will give me my z value. So just to remind everybody, if you select menu and then select 7, inverse normal is the third option, type in the area of 0.9, sigma is 1 and mu is 0, and that gives us an answer. It gives us an answer of 1.281624 dp. Using this z value, I can equate my 6 over sigma with 1.2816. So let's do that. 6 over sigma equals 1.2816, and therefore sigma is equal to 6 divided by 1.2816, and that is going to give me an answer of 6 divided by 1.2816, 4.68164, which is 4.6823 SF. That's the solution for part A. For part B, we've been asked to work out the percentage of calls that take less than 13 minutes. So I will just quickly sketch another diagram, and this is x is normally distributed with mean of 16, but the sigma I now know is 4.68. I'm going to use a more accurate value. which is 4.68164 squared, and that's 16. So less than 13 minutes is going to be this area here. What's the area? That's what we're being asked. So probability that x is less than 13 is equal to, use normal CD on your calculator. Normal CD upper is going to be equal to 13, and your lower will be equal to minus 100,000. Any very small number will do. And now I'm just going to put that in a calculator with our mean of 16 and our sigma of 4.68164. Always use more accurate values if you're going to use statistics in subsequent questions. So menu 7, normal CD, the lower value is minus 100,000. Upper value is going to be 13. Sigma is 4.68164. And your mean is 16. And the answer that I've got from my calculator is 0.2608 to 4 dp.